Right now, a factory-enabled setting inside your engine is grinding down lifters, starving oil from bearings, and building toward a $3,000 to $5,000 failure your dashboard will never warn you about. I've spent over 20 years pulling apart engines that died before their time, and most of that damage wasn't caused by neglect. It was caused by settings the manufacturer turned on before you ever picked up the keys. These 11 are the worst, and number 1 will change how you look at your instrument cluster permanently. Starting at number 11, we have the fuel saver that's eating your engine alive. I pulled the valve cover off a 2018 Silverado last spring. 62,000 miles. Oil changed on schedule, driven normally, single owner. 2 collapsed lifters and a cam lobe worn flat. The truck sounded fine at idle. No codes. No light on the dash. The only clue was a faint tick at cold startup that the owner wrote off as normal diesel-like clatter. What was actually happening is something I see 3 or 4 times a month. That's active fuel management. GM calls it AFM. Honda calls it VCM. The newer version is dynamic fuel management. Whatever the badge, the concept is the same. The ECU deactivates cylinders under light load to save fuel. Sounds efficient on paper. In practice, those deactivated cylinders create uneven oil distribution across the valve train. The lifters that cycle on and off thousands of times per drive develop internal collapse over time. They stop holding hydraulic pressure, and when they collapse under load, they hammer the cam lobes with metal-on-metal impact that no amount of oil can protect against. The filter catches some debris, but never enough. Once a lifter fails, it takes the camshaft with it. I've seen this exact pattern on GM Vive 8s going back to 2007 and Honda V6s from roughly 2005 through 2020. Honda's V6 oil consumption issues during that era are directly connected to VCM cycling, wearing out rings and guides unevenly. Newer DFM systems on GM 4-cylinders are better designed, but they're not immune. The fix is a plug-in AFM disabler. Runs about $150, or in some cases, a dealer-level reflash that locks all cylinders active full-time. Either way, you're choosing slightly more fuel now instead of a cam and lifter set later. That trade makes sense every time. But deactivating cylinders isn't the only way your car quietly overworks itself at low RPM. Coming in at number 10, Eco Mode is lugging your engine into an early grave. That green leaf icon on your dashboard feels responsible, feels like the smart choice. Here's what Eco Mode actually does on most modern automatics. It forces the transmission into the highest possible gear as early as it can, holding engine speed abnormally low under load. That condition is called lugging, and it's one of the most destructive things you can subject a drivetrain to over tens of thousands of miles. When an engine lugs, crankshaft flex increases because there isn't enough rotational momentum to smooth out combustion pulses. Oil pressure drops because the pump spins slower. On direct injection engines, low RPM underload is the exact condition that accelerates carbon buildup on intake valves. No port injection to wash them clean. Timing chains stretch faster under inconsistent tension. Main bearings wear unevenly from oscillating loads. The engine works harder despite the lower RPM number, and the transmission compensates with more torque converter slip, generating heat that degrades fluid chemistry and glazes clutch packs over time. You won't feel any of this happening. The car just gradually feels less responsive, and you blame age or mileage when it's actually the mode you've been leaving on since you drove it off the lot. CVTs and 8+ speed automatics paired with turbocharged engines are the worst offenders because their torque bands are narrow and factory calibration leans heavily into fuel economy numbers. Naturally aspirated engines with broad power bands handle it better, but even those aren't designed to hold 1200 RPM up a highway grade with passengers and cargo. Use Eco on flat highway at steady cruise. Anywhere else, turn it off and let the engine work where it was designed to. If Eco Mode is quietly wearing your drivetrain down, the next setting does the same kind of damage. 30,000 extra times per year. At number 9, your engine restarts 30,000 extra times a year and nobody told you. Every red light, every drive-through lane, every pause in traffic, the engine shuts off and fires right back up. That's auto start-stop. And it's the single most complained about factory feature in modern vehicles. Manufacturers say the starter and battery are engineered for this cycle count. Technically, they are. Enhanced starters have beefier contacts and heat-resistant windings. AGM batteries handle deeper discharge. But here's what doesn't make the brochure. Every restart is a brief oil starvation event. Oil drains off bearing surfaces during each shutdown window, and the restart loads the crankshaft before full hydrodynamic film pressure rebuilds. That load lands on bearings that aren't fully protected yet. Multiply that by dozens of cycles per commute, thousands per year, and you get cumulative thermal cycling stress on rod and main bearings that no start-stop algorithm fully compensates for. Then there's the battery. AGM replacements run $200 to $400, and they degrade faster in hot climates. Exactly where start-stop cycles the most frequently. The starter motor, even the heavy-duty version, still has a finite engagement life you're burning through at roughly 10 times the rate of a conventional system. Now, vehicles with 48-volt mild hybrid systems handle this far more gracefully. They use a belt starter generator instead of a traditional starter motor, and the restart is smoother, faster, and dramatically easier on bearings. If yours uses a standard 12-volt system, the dashboard button disables it per drive. Some owners use OBD coding tools to make the disable permanent. As long as emissions hardware stays untouched, that's a perfectly reasonable decision. If this kind of information saves you even one expensive repair, subscribe. That's all I'll say about it. Number 8 on the list. Your dashboard is hiding the one number that could save your engine. Look at your temperature gauge. That needle sitting dead center? It's been parked right there since 5 minutes after cold start. It'll stay in that exact position until your engine is on the edge of real, costly damage. That's intentional. Modern gauge clusters compress a 40-degree plus temperature range into one center position on the dial. Your engine could be running 15 or even 20 degrees hotter than its normal baseline, and the needle won't flinch. By the time it creeps toward red, you're already staring at a warped cylinder head or a compromised head gasket, damage that starts in the 4-figure range and climbs from there. The actual coolant temperature number is buried in an infotainment submenu on most Toyotas, Hyundais, and Fords. On some, you can access it through an instrument cluster button combo. On other makes, a $10 OBD2 Bluetooth adapter and a free phone app gives you the exact reading in real time. Either way, you should be monitoring your engine's actual operating temperature, not a flattened, deliberately vague gauge designed to keep you calm and out of the service bay until it's too late to save the repair bill. 15 degrees caught early is a $40 thermostat. Caught late, it's headwork, gasket replacement, and a machine shop visit. That gauge isn't the only system in your car staying quiet when it shouldn't. Landing at number 7, your transmission learned your worst habits and never forgot them. A customer brought me a 2019 F-150 last fall. Shifts felt mushy, delayed, and the transmission hunted between gears on every slight grade change. 38,000 miles, no diagnostic code stored, no fluid leaks. Fluid itself still looked pink and smelled clean. The problem wasn't mechanical, it was behavioral. The previous owner was a fleet driver who spent 2 full years crawling through downtown traffic at walking speed, rarely exceeding 30 miles per hour. The transmission's adaptive shift algorithm had quietly calibrated itself around that input pattern. Soft engagement points, delayed upshifts, excessive torque converter slip on every acceleration event. Nobody felt it happening because the change was gradual over thousands of miles. But that constant slip generates heat, and heat is what kills automatic transmissions. It degrades fluid chemistry, glazes clutch friction material, and distorts the precision bores inside the valve body. The transmission doesn't understand it's shortening its own life. It believes it's performing exactly as instructed. This applies across virtually every modern platform. Z F8 speeds, GM Hydramatics, Ford 10 speeds, Nissan Jatco CVTs. CVTs are especially sensitive because belt friction behavior changes directly with software calibration, and a lazy calibration promotes belt slippage that accelerates wear on the pulleys themselves. The fix is a transmission adaptive memory reset. On some vehicles, a 15 to 20 minute battery disconnect clears the learned shift tables. Others require a basic scan tool to wipe the data. After a reset, drive normally for about 50 miles, and the system relearns around your actual driving style. Cheapest transmission service you'll ever perform, and one of the most effective. The next problem isn't something any reset can fix. It's a federal standard baked into every tire pressure sensor sold in this country. Down to number 6. Your tire pressure warning lets you run 8 psi low before it even notices. Federal TPMS regulations only require a dashboard warning at 25% below placard pressure. On a vehicle rated for 35 psi, that means the light won't come on until roughly 26 psi. Think about that number for a second. At 26 psi, sidewalls are flexing well beyond their designed range. The contact patch is deformed, rolling resistance has climbed substantially, and the engine is hauling harder on every single mile just to maintain speed. Heat builds inside the tire casing, the #1 cause of sidewall blowouts. Fuel economy drops noticeably. Tread wears unevenly at the outer edges, shortening tire life by thousands of miles. And through all of that, you have zero indication on the dash that anything is wrong. I've had tires come across my lift at 28 psi, 7 pounds low, running that way for months. The owner saw no light and assumed everything was fine. Why wouldn't they? That's what the system is designed to communicate. Some luxury brands allow threshold adjustment through infotainment. Most mainstream vehicles don't offer it. The fix is behavioral, not digital. A $3 pencil gauge and 60 seconds once a month. Check cold before you drive anywhere. Cheapest habit on this entire list, and one of the most impactful for engine load, tire longevity, and fuel economy combined. You're halfway through this list, and if you're starting to see a pattern, good. These aren't obscure failure modes. They're factory defaults on vehicles in dealer lots right now, and the back half hits harder. At number 5, your remote start is either cooking or starving your engine. Cold morning, hit the fob from the kitchen. Engine fires up and idles for 10, maybe 15 minutes while you finish getting ready. Feels like responsible ownership. It's doing quiet, cumulative damage. Extended idle on a modern engine, particularly direct injection, is one of the harshest operating conditions you can subject it to. At idle, combustion temperatures stay too low for complete fuel burn. Unburned fuel washes past piston rings and dilutes the crankcase oil, a condition called fuel dilution that accelerates bearing wear and thins the oil's protective film. Carbon deposits pile up on intake valves because airflow at idle isn't strong enough to scour them clean. The catalytic converter never reaches efficient operating temperature, which promotes internal degradation. Oil circulation barely exceeds baseline because the pump only turns at idle speed. On the opposite extreme, a 2-minute remote start in sub-zero weather sends you driving before oil reaches full operating viscosity, which means metal-on-metal contact at every bearing surface until the engine warms under load. The ideal window is narrow, 3 to 5 minutes in serious cold, just enough for oil to circulate and the idle to stabilize. In warm weather, 30 seconds and drive gently. Most factory remote start durations are adjustable through the infotainment system or the fob's programming sequence. Check your owner's manual. Diesel and turbocharged engines have slightly different warm-up considerations, but the principle is universal. Idle time should be a tool you use intentionally, not a default habit you never questioned. Idle damage compounds slowly over months. The next setting can spike thermal stress in a single hard afternoon drive. Coming in at number 4, Sport Mode's boost map is shortening your turbo's life every time you select it. Rebuilt a turbo on a 2020 BMW 330i last year. 44,000 miles. Full synthetic changes on schedule. 0 warning lights ever stored. The turbo bearings were scored. The wastegate actuator was sticking intermittently, and the oil feed line showed visible coking, baked on carbon deposits from oil that exceeded its thermal tolerance too many times. The owner drove in Sport Plus mode for nearly every mile he put on the car. He thought it was a harmless preference. It wasn't. On a turbocharged vehicle, Sport mode doesn't just sharpen the throttle, it raises target boost pressure, holds gears longer at high RPM, and pushes exhaust gas temperatures significantly above normal mode levels. The turbocharger, already operating near its design thermal ceiling under everyday driving, gets pushed beyond that margin with every sustained acceleration. Oil temperatures spike on the turbo's oil feed line. The intercooler works overtime to cool charge air. Exhaust manifold thermal cycling accelerates, stressing the housing, welds, gasket surfaces, and the wastegate actuator mechanism. Occasional use is perfectly fine. The car was engineered to deliver those bursts of performance safely, but sustained daily use across 40,000 miles, every commute, every merge, every errand run in Sport Plus compresses the turbo's service life dramatically. Replacement runs $1,500 to $4,000 depending on the vehicle. The prevention costs $0. Use Sport when you want it, then drive the final few minutes of your trip in normal mode. Let oil circulate through the turbo bearing housing at lower temperatures before you shut down. That single cool-down habit can double turbo bearing service life. For naturally aspirated vehicles, Sport mode primarily adjusts shift points and throttle mapping. The thermal stakes are far lower and far less consequential. Sport mode is a conscious choice you make. The next setting runs in the background silently every time you start your vehicle. Number 3 on the countdown. Your AC compressor runs 11 months a year and you never switched it on. Press auto on your climate control system. It takes over fan speed, temperature blend, vent direction, and one thing you probably didn't expect, whether the AC compressor engages. In nearly every vehicle I've worked on, auto mode activates the AC compressor year-round for cabin dehumidification. January, February, bone-dry weather, doesn't matter. The compressor cycles. That's a constant parasitic drag on the engine. A 2 to 5% fuel economy penalty running quietly in the background. It puts continuous stress on the serpentine belt and accumulated wear cycles on a compressor clutch that has a finite service life. Compressor clutch failure typically surfaces between 100 and 150,000 miles, and the replacement cost escalates quickly, especially on vehicles where the compressor sits buried behind engine accessories and requires hours of labor just to access. The fix takes 1 second. Press the AC button on your climate panel to disengage the compressor when dehumidification isn't needed. Dry winter mornings, cool fall evenings, any day where fogged windows aren't a concern. The climate system still blows air at whatever temperature you've set. The engine just stops carrying the extra parasitic load. Electric compressors on hybrids and EVs don't burden the engine this way at all. Variable displacement compressors reduce the drag significantly, but on a conventional gas vehicle with a fixed displacement compressor, that single button press saves more fuel, belt life, and compressor longevity than most people would ever guess. The last 2 settings are the ones I see cause the deepest long-term invisible engine damage, and almost nobody knows they exist. Now at number 2, your ECU silently downgraded itself because of your gas station. Pulled live data on a 2021 Accord last month. No check engine light, no drivability complaints from the owner, but long-term fuel trims sat at positive 8%, and the NOx sensor log showed hundreds of minor timing retard events spread across the previous 10,000 miles. The owner had been filling up with 87 octane since the day he bought it, in a car that specifies premium recommended. Here's the mechanism nobody explains at the pump. The ECU constantly monitors NOx sensor feedback and adjusts ignition timing in real time. When it detects detonation, even micro knock events you'd never hear or feel, it retards timing incrementally, a fraction of a degree at a time. Over thousands of miles on lower octane fuel, the long-term adaptation window shifts into a permanently conservative position. The engine now runs a degraded ignition map. Power drops. Exhaust temperatures rise. Thermal load on the catalytic converter increases month over month. And here's the part that catches most people off guard. That adaptation doesn't always fully reverse when you switch back to premium. The ECU relearns in both directions, but it does so slowly and cautiously. Long-term trim values can take thousands of miles to normalize. If your vehicle says premium required, there's no discussion. Run it or risk detonation damage. If it says premium recommended, running regular means the ECU is actively degrading its own performance calibration as a self-preservation response. The engine works, but it works in a compromised state that was never part of the original engineering target. Turbocharged engines with high compression ratios are the most sensitive to this. If you've been running regular for extended mileage, fill 3 consecutive tanks with top-tier 91 plus octane, then disconnect the battery for 15 minutes to clear the adaptive memory. Give the ECU a fresh start on the fuel it was designed around. And that brings us to the single most trusted readout on every modern dashboard, and the one that gets it wrong the most often. And at number 1, the oil life monitor doesn't know what your oil actually looks like. Every owner says the same thing. I change my oil when the car tells me to. They believe that percentage, 40% remaining, 30%, whatever the screen reads, reflects the actual condition of the oil sitting in their crankcase. It doesn't, not even close. Oil life monitors are purely algorithm-based. They estimate remaining useful life from RPM data, temperature readings, calculated engine load, and elapsed calendar time. They never measure viscosity. They never detect acid buildup. They never test for fuel dilution, which is a serious and growing problem on GDY and turbocharged engines where unburned fuel slips past piston rings and thins the oil from the inside out with every combustion cycle. The algorithm assumes a set of ideal operating conditions that most real-world drivers never actually meet. It doesn't know your commute is 6 miles of stop and go in Houston's summer heat. It doesn't account for your turbo pushing oil temps 15 degrees past the model's thermal baseline. It doesn't factor in that your fuel trims are running slightly rich and dumping extra gasoline into the crankcase on every cycle. I've sent oil samples to Blackstone Labs at 30% life remaining on a GM truck, a reading that should mean plenty of protection left, and gotten results showing the oil was already past its functional limits. Viscosity had broken down below the minimum threshold for the grade, where metals were elevated across the board. Iron, copper, aluminum, all trending upward. The total acid number was climbing toward condemning levels. The monitor said 30% remained. The lab said 0. The fix isn't expensive, and it isn't complicated. A used oil analysis costs about $30. Send a sample at your normal change interval, wait a week for the report, and calibrate your personal change schedule around actual laboratory chemistry, not a calculated estimate displayed on a screen that has never seen a drop of your oil. GM, Honda, and Ford oil life algorithms vary significantly in how conservative they are. Some stretch intervals further than others. Diesel engines and turbocharged gas engines almost universally degrade oil faster than any factory monitor accounts for. Trust the analysis, not the number. Every setting on this list came from the factory enabled, and every one trades long-term engine health for a spec sheet number or a compliance checkbox. Check the ones that apply to your vehicle. Adjust what you can, and stop trusting the dashboard to tell you the whole truth.